Hey everyone, this is Abinash Behera and welcome back to another video. Today we are diving deep into one of the most important and powerful concepts in programming, object-oriented programming, or simply OOP. And we will be exploring in the context of C#. If you have ever wondered how big applications like Instagram, Microsoft Word, or even Unity games are structured so beautifully, it's because of object-oriented programming. So grab your copy, stay with me till the end, and let's get started. First, we'll talk about history and evolution. Before the 1970s, software was written using procedural programming, was written out in series of instruction steps. It worked fine for small programs, but as applications grew larger, it became messy and difficult to manage. In the 1967, Ole John Dahl and Christian Nygaard, two Norwegian scientists, created the first OOP language called Simula. It introduced classes and objects. Later in the 1980s, C++ made OOP popular, followed by Java in 1990s, and finally C# in the early 2000s, developed by Microsoft under the .NET framework. C# took the best features from C# and Java, making OOP modern and developer friendly. So, what is object-oriented programming? OOP is a programming style that organizes code around objects, real entities like cars, students, or bank accounts. Each object has attributes, data, and behaviors methods. Example, a car object can have attributes like color, brand, speed, and methods like accelerate. Instead of focusing on just procedure, OOP combines data and logic together in one place, the class. So I will explain all the example later. So why OOP is important? OOP helps make code modular, reusable, and easier to maintain. It allows developers to model real-world systems directly in code. Modern languages like Java, Python, and C# are all object-oriented because it provides structure, scalability, and clarity. Four pillars of OOP, the core principles like encapsulation, abstraction, inheritance, and polymorphism. Now we'll talk about encapsulation. Encapsulation means wrapping data and methods that operate on the data inside a single unit or a class. Example is there is a class student, private int marks, public void set marks, where we pass an argument as m, marks equal to m, and public int get marks, and we're returning the marks. Here marks is private. It can only be accessed through public methods. This hides sensitive data and protects it from accidental misuse. Real world analogy. Your smartphone hides complex hardware behind a complex, simple touchscreen interface. That this is encapsulation. Now we'll talk about abstraction. Abstraction means showing only the essential details while hiding unnecessary complexity. Example, in calculator, we are adding in addition, we take two integers a and b and returning a plus b. So without knowing how the addition implemented internally, C achieves abstraction using abstract class and interface. In real analogy, we can say when you withdraw money from an ATM, you just press button. You can see how the machine comes. Now, come to inheritance. Inheritance allows one class to inherit upon each behavior from another. Becomes showing inherits behavior when classes with methods. This promotes for reusability. Concept of inheritance is single, multi-level, hierarchical, and multiple. We can achieve multiple inheritance by using intermediate. Here we are saying star inherits several features, making space. Polynomial means many forms. It allows methods to be different depending on object or input. For example, the raw method behaves differently based on which value it calls. The word raw changes meaning depending on context. You can have more and security. Modularity means divide large programs into smaller parts. Reusability means using existing code again and again. Scalability means exact, easily extend and security means example more useful flexibility between model. The quickness of their mechanically and it represents real system clearly. So what is the real world uses in it? If it's games, so model players, weapons, and environments. In banking, encapsulation protects balanced data. In web apps, ASP.NET uses inheritance and abstraction. In software design, OOP makes teamwork and code sharing easily. So, what are the advantages than procedural programming? So, in procedural programming, what is going on? Like it is on based on functions, and here data and logics are separate. It is hard to manage in large system. But in case of object-oriented programming, it combines data and logic, promotes reusability and structure, easier to maintain and scale. So the summary is encapsulation protects data, abstraction hides complexity, inheritance reuses code, and the polymorphism adds flexibility. Together they make software smarter and more maintainable. And that's everything about object-oriented programming in C Sharp. From its birth it in the 1970s to today, it's a massive system. Hope remains the foundation of modern development. If you found this helpful, don't forget to like, share, and subscribe for more coding tutorials. Thank you for watching. I'm Abinash Behera, signing off.